So we reached the final section in Chapter 11 of Young and Freedman's University Physics on elasticity and plasticity. So this chapter has been about equilibrium, and it's been about stress and strain in the more recent sections. The final section basically gives this chart. This chart pretty much sums up the final section, although I've drawn this one. Basically, we're plotting stress versus strain here with regard to any particular material. And I'm just in awe of the people who've gone before us, the physicists who've experimented and put these things together. This is just brilliant. But anyway, as simple as it is. So basically, the original line here, this is the kind of elasticity part of when let's say you're stretching something or whatever you're doing. Maybe you're bulking or shearing, but there's a point where there is this proportionality. Remember that we've said throughout that stress and strain are proportional within a certain region. Well, this region right here of elasticity, for some proportion of stress and strain, for some amount of stress, there will be a proportion between stress and strain. But then it reaches a point A here, a proportional limit. At the proportional limit of a particular material, then the ratio between stress and strain ceases to be proportional. And so you can see that from A to B here, we have a point where it's not proportional. Maybe I've drawn it badly, but the proportion between stress and strain, it's not proportional. Once you get beyond the proportional limit, you've stretched it so far that it's no longer proportional between stress and strain. But before we get to this solid line here, it's elastic. This is an elastic phase right here. And what that means is that if you let go, it's going to go back to its original shape. So proportional limit is where it stops being proportional, but there's still up until what's called the elastic limit, or the yield point, which is going to be different for different substances. But once you get to the elastic limit, right before you get to it, anytime in this area to the left here, anytime you're in this part to the left, it will go back to its original shape. That's the elasticity phase, as it were. But once you get beyond the elastic limit of a substance, you have a deformation of some kind. So anywhere in here, from B to fracture point, it's not going to go back to its original shape. It's going to be permanently reset in a different shape once you let go. And so this permanent set point here is basically what it goes back to after you've let go, once you're past the elastic limit. But once you've crossed the elastic limit, it's not going to go back to its original shape. And so we call this a phase of plasticity rather than elasticity. And the elastic part, it goes back to its original shape. But in the plastic part, it doesn't. It's going to go back to some other permanent set shape. Now, eventually there's a fracture point. That's where basically it's going to break. You've deformed it so much, it's just going to rip. And so how far you go beyond the elastic limit is whether we call it, for example, ductile. Ductile means that you can still pull for a little bit beyond the elastic limit and it's still not break. If something's brittle, that means it's going to break very quickly after you've reached the elastic limit, which may be very small. So again, this is a lovely chart that kind of captures something we experience in everyday life, that we can pull something, you can stretch something so far and then it's going to break. And some things don't stretch much at all. So this is a great chart that summarizes this last section. There are some other terms in this final section, which is very short. It's about a page long, that should be mentioned. So I've already mentioned the distinction between ductile and brittle. If something is ductile, then it can still stretch beyond its elastic limit before breaking for a little bit. If something's brittle, it's going to break pretty much once you pass the elastic limit. There's also something called elastic hysteresis. That's where it's not proportional in its stretching at all, and that it in fact, when it goes back to its original shape, it doesn't go back in exactly the same way that it's stretched in the first place. So that's called elastic hysteresis. Finally, there is what that fracture point is the breaking stress point. How much stress does it take to break it? That's breaking stress or ultimate stress. Or if we're stretching, it's tensile. The tensile strength of something is how much stress you can put on it before it snaps. That's the tensile strength. Breaking stress and ultimate stress could involve other kinds of stress as well. So there you have it, the final section of Chapter 11 of Young and Freedman's University Physics on elasticity and plasticity.